Add this information to your periodic table. First, write the word diatomic somewhere and highlight it. Then I want you to highlight the diatomics on the periodic table. I also want you to list where the noble gases are, and especially important in naming is the line that separates metals from nonmetals. So we're going to write nonmetals are on the right side of the stepladder and that the metals are on the left-hand side of the stepladder. When we are naming, when we're looking at it at the beginning before we get super comfortable with naming, we want to reference this chart. We'll always work our way down. Is it a single element? No. Then we ask ourselves, does it have a negative charge? If no, then does it have a positive charge? If no, is it a covalent molecule? Is it two elements that are both nonmetals in the formula? If not, then is it an organic? And if not, is it ionic? And if it is ionic, is it an acid or is it just a regular salt? Example 1, Au. We have a single element, so we take the name directly off the periodic table. So I look for Au on the periodic table. I find that it is number 79. I take the name directly off that periodic table, so Au is called gold. Example 2, Br2. I do not have a single element because I have two Brs. I don't see a negative charge. It does not have a positive charge. Is it a covalent? Well, covalents are molecules made up of two nonmetals, and I only have one element there. But at the bottom of the covalent box, it says diatomics are also covalent molecules. But names come directly from the periodic table, so we don't use covalent prefixes. The name comes directly from the periodic table. And just like O2 is just called oxygen and oxygen is O2, Br2 is just called bromine. Example 3. I don't have a single element, but I do have a negative charge. And when I have a negative charge, I take the name directly off the common negative ion table, found in the top right-hand corner of your pink sheet. And SO4 2- is called sulfate, so I write sulfate. Example 4, Fe2+. It is not a single element. Well, it's by itself, but it has a charge. So it's not an element all by itself. It is carrying a charge. It is not a negative charge. It is a positive charge. And when I have a positive charge, I take the name directly off the periodic table. So I look for Fe, and I will call it iron. It is then followed by brackets if the cation can have more than one charge option. So I write iron. It has more than one charge option, so it will need a Roman numeral. And in this case, Fe is taking a +2 charge. So I call it iron 2, and then I follow with the word ion, which signals that it has the positive charge. Example 5, KBr. I don't have an element all by itself. There's not a negative, nor is there a positive charge. It is not made of two nonmetals. There are two elements there, but potassium is a metal. It's not organic because I don't have carbon. Ionic, is it made of a cation and an anion? Well, potassium can take a positive charge, and Br is found on our negative list, so it is an ionic compound. So K is called potassium. No Roman numeral required because it can only have a +1 charge. And then that's followed by the name of the negative ion, which is bromide. Example 6, HClO2. We don't have an element all by itself. There are no charges, so it can't be a negative or positive charge. It can't be covalent because I have more than two elements in the formula. It can't be organic because I don't have carbon. So it has to be an ionic. And I have H plus on the front, so that makes it an acid. H plus mixed with, and I look on my negative list on my data table, I find ClO2 minus, which is chloride. So I have H plus mixed with something on my negative list. It is for surely an acid. So I have to use my acid naming rules. Chloride ends in ite. So when I have something that ends in ite, I cross out the ite and change it to us. And that will give me chlorous acid because it says change ite to us and end with the word acid. Example 7, HF. Again, not a single element, and we don't have any charges. It's not covalent. We have two elements, but hydrogen is not a nonmetal. We don't have any carbon, so it can't be organic. So that means it has to be ionic. And it's one of those ionics that starts with a hydrogen. So we're looking at acid naming. I look up F on our negative list and I find fluoride. And then I look at my acid naming rules. And when I have ide, I add hydro to the front and I change ide to ic. And then I finish with the word acid. So HF is called hydrofluoric acid. Example 8, C2S4. I have two elements here, so it's not a single element. There is no charge, so it's not a negative, nor is it a positive. Is it a covalent? I do have two elements, and they are both nonmetals, so this is a covalent molecule, and I will have to use covalent naming. So I'll go to my pink sheet and look at, on the data table, our covalent numbering. So a covalent prefix identifies the number of each element. If I have two carbons, 2 is di, so I would call 2 carbons dicarbon. I have 4 sulfurs, 4 is tetra, but remember the ending of the name is always changed to ide. So I wouldn't call it tetrasulfur, I would call it tetrasulfide. Example 9, CO. Again, I have two elements here, carbon and oxygen, so it's not a single element, nor do we have a negative or a positive charge. It is a covalent molecule because it is made up of two nonmetals. So I will need to use my covalent prefix data table. I have one carbon and one oxygen, so I'm using the prefix of mono. Now remember, there's an asterisk there because mono is never used on the first element. So since I have a single carbon, I would not call it monocarbon because mono is never used on the first. So I just write carbon. Mono can be used on the second. And remember, we always change the end of the name to ide. So it isn't monoxygen, it's monoxide. So CO is carbon monoxide. Example 11, H2SO4. We obviously don't have a single element, nor do we see a negative or positive charge. It's not covalent because we have more than two elements. It's not organic because we don't have carbon. So therefore, by process of elimination, it must be ionic. And we see it starts with an H. It's got H plus mixed with some negative anion. So therefore, it's an ionic acid. So I need my acid naming box. And it says change the name based on what the anion is. So if I have H plus on the front, and I have two of those, that means my negative must be SO4 2 minus. So I go to the negative list on my pink sheet and look up SO4 2 minus, which is sulfate. Now in the acid naming box, it says if I have 8, I change 8 to ic, and I follow with acid. So that gives me an answer of sulfic acid. But that does not sound right. At the bottom of the box, it says the exception in suffix is sulfur and phosphor. So it wouldn't be sulfuric acid, it would be sulfuric acid. Example 12, Cu3PO4. Again, not a single element, nor do we see a negative or positive charge. It's not a covalent because we have more than two elements. Not organic because we don't have any carbon. So therefore it must be ionic. And since we don't see an H, it's obviously not an acid. So we're looking at the ionic box, the ionic naming. So the formula has a cation and an anion. Remember, cation is positive, anion is negative. The cation is listed first, and that would be copper because it's at the start. Positive is always written first. It is then followed by brackets if the cation has more than one charge option. Well, we'll look up copper. It says copper can be a +1 or a +2, so we will need Roman numerals. How are we going to figure out which charge it's taking? Well, we're going to find out through the back end charge. So I'm going to have to look up the negative, which is PO4, and that is phosphate, and it tells me that PO4 has a -3 charge. So I've got PO4 with a 3- charge on the back, and I have 3 coppers on the front. Now remember, the back end charge has to equal the front end charge. So if I've got a -3 on the back end, I need a +3 on the front end. And if I have 3 guys there sharing a +3 charge, that's a +1 each. So that means I've got copper with a +1 charge mixed with phosphate. So that's copper with a +1 phosphate. That's copper 1 phosphate. Example 13, H3PO4. We don't have a single element. We don't see a negative charge or a positive charge. It can't be covalent because we have more than 2 elements. It's not organic because there is no carbon, so therefore it must be ionic. And it is an ionic acid because we see there's H plus mixed up with something we find on our negative list. So I bring up the acid naming box and change the name based on what the anion is. PO4 is our anion, and we know it has a -3 charge because on the front end, there are 3 H pluses. So PO4 3- is called phosphate, and it ends in 8. So I'm told to change 8 to ic and follow with acid. So our answer is phosphoric acid, which is wrong. We're told there's an exception in suffix of sulfur and phosphor. So it's not phosphoric acid, it is phosphoric acid. Example 14, CO3, bracket PO4, bracket 2. Not a single element. I don't see a negative charge or a positive charge. Can't be covalent because we definitely have more than 2 elements there. Not organic because we don't have carbon, so it must be ionic. So I have a cation, which is positive, followed by an anion, which is negative. The cation is listed first, and it's followed by brackets if the cation has more than one charge option. So I look up cobalt, and I see I will need a Roman numeral because it has more than one charge option. That will then be followed by the anion, which again is PO4, which is phosphate with a -3 charge. Now I have 2 phosphates, and on the front I have 3 cobalts. The 2 phosphates on the back end will give me a total -6 charge, which means I must have a total +6 charge on the front. So if I have 3 cobalts and they have to add up to a +6, that means they have to have a +2 each. So this is cobalt 2. So I have cobalt 2 phosphate. Example 15, bracket NH4, bracket 2, CO3 dot 2H2 whole. Definitely not a single element. I don't have a negative charge or a positive charge. Definitely not covalent because we have way more than 2 elements. Organic, well, it does have carbon, but we have a lot more than carbon, hydrogen, and oxygen there, which is the extent of the organic molecules we will be dealing with in this course. Ionic, it has to be. And it's not an acid because it's not H plus mixed with a negative. We got a lot more going on there. So I have a positive and a negative. Nowhere on the table do I find NH4. Not on the periodic table, but in the data tables, I have my common positive ions. And NH4 plus is called ammonium ion. And on the back end, I have carbonate, which is CO3 minus. So that means my salt is ammonium carbonate, but I still have to deal with that weird dot 2H2O at the back. Also, on my sheet in my data tables, I find this box. It says hydrated compounds. In the formula, a dot is placed between the ionic formula and the number of waters coordinated around the salt. And that's what we see. We have our salt of ammonium carbonate and then dot 2H2O. Now we are doing the naming part. So it says in the name of the ionic compound, it's followed by a covalent prefix identifying the number of water molecules followed by the word hydrate. Hydrate meaning waters, right? We're hydrated, we have water. We're dehydrated, we need water. So hydrated is water. So we need a covalent prefix, and then we follow it with the word hydrate. So I look at my covalent prefixes, and I've got two waters, and the covalent prefix for two is di. So two waters is dihydrate. So this thing here is called ammonium carbonate dihydrate. Now it's time to start working on the BR8 and 9 assignment.